Good morning student, class 9, chapter 1st, number system. This is a second lecture of number system. So let us continue. Real numbers and their decimal expansions. The first one, terminating decimals or terminating numbers. The decimal expansions ends or terminates after a finite number of steps of division. Such decimal expansions are called terminating decimals. For example, when you will divide 3 by 4, here you will get quotient 0.75 and remainder is 0. So I will able to write 3 by 4 as 0.75. So it is terminating decimal. The second, non-terminating decimals. In these divisions, the decimal expansions never comes to an end. Such decimal expansions are called non-terminating, that is, when the remainder never becomes 0. For example, when you will divide 11 by 30, your quotient will be 0.36666. It will go endlessly, and in this case, remainder is non-zero. So, this is non-terminating decimals. Now, the third is reoccurring decimals. It is a non-terminating decimal in which a digit or a group of digits is repeated continually is called a reoccurring or repeating decimals. For example, when you will divide 2 by 9, you will get 0.222 continuously. Here you can see which digit is repeated? 2. So when only one digit repeats, a bar is put above it. Thus 2 by 9 is equal to 0.2 bar. Second example, 7 by 22. When you will divide 7 by 22, you will get the quotient 0.3181818 going on endlessly. So here only 18 repeated. So I will able to put the bar only upon 18. So I will able to write 0.318 bar. Only bar is upon 18. I will able to write 0.318 bar. Now next, the decimal expansion of a rational number either may be terminating or non-terminating reoccurring. For example, 1 by 2. When I will divide 1 by 2, I will get 0.5. It is a terminating rational number because in this case remainder is 0. And one more example, 1 by 3. When I will divide 1 by 3, you will get quotient 0.333 going on endlessly, and the remainder is non-zero. I will able to write it as 0.3 bar. It is a non-terminating reoccurring rational number. Why reoccurring? Because 3 is repeated so many times. It will not stop. That's why it is non-terminating reoccurring rational numbers. So that means rational numbers are either terminating or non-terminating reoccurring. Now the question arises, what about the irrational number? So the decimal expansions of an irrational number is non-terminating, non-reoccurring. Conversely, a number whose decimal expansion is non-terminating, non-reoccurring is irrational. Let us take one example. Pi value is 22 by 7. When you will divide 22 by 7, you will get 3.141592653 going on endlessly. And it is what? Irrational number. Again, second example, under root 2. The value of under root 2 is 1.41421356 going endlessly. Again, it is an irrational number. Let us solve one problem based upon this. Find decimal representation of 8 upon 45. When I will divide 8 by 45, you can see we will get quotient 0.177 going on endlessly. Here remainder is again non-zero. So I will able to write 8 by 45 as 0.177 going on endlessly. Here only one digit is repeated. So I will able to write it as 0.17 bar. Let us solve exercise 1.1. First question, is 0 a rational number? Solution, yes, 0 is a rational number. Why? Because I will able to write 0 as 0 by 1 or 0 by 2 or 0 by 3. Because when you will divide 0 by 1, again the answer is 0. Now here 0 by 1, that is in the form of p by q, and q is non-zero. So it is a rational number. Second question is find 6 rational numbers between 3 and 4. Now solution. Now 3, may I write 3 as 3 by 1, 4 as 4 by 1. So I will multiply numerator and denominator by 100. I will get 300 by 100. And similarly 4, I will multiply 4 with 100 and the denominator 1 by 100. And you will get 400 by 100. So there are so many rational numbers lying between 300 upon 100 and 400 upon 100. So you can choose any 6 rational numbers which are lying between 300 by 100 and 400 by 100. Now the next question number 4. State whether the following statements are true or false. The first one, you have to justify the answer with the example also. The first, every natural number is a whole number. So answer is true. Why? Because the collection of whole numbers contain all the natural numbers. You know the definition I already given. The whole number contains all the natural numbers. So every natural number is a whole number. Second one, every integer is a whole number. Answer is false. Reason, negative integers are not whole numbers. Example, -2, -3, -4 and so many examples are there. All these are negative numbers, but they are not whole numbers. Third one, every rational number is a whole number. The question is, every rational number is a whole number. Answer is false. Reason, for example, 1 by 2, 1 by 3, 1 by 5. You can take any example of rational. Now you can see 1 by 2. It is a rational, but it is not a whole number.